So looking at this red parabola right now, can we see that it's not passing the vertical line test? Our original function isn't passing the vertical line test. And so the inverse of this graph is not going to be a function if we did the inverse of the whole thing. Now the question says, determine two ways to restrict the domain so that the inverse is a function. So if I took out a highlighter, how much of this graph could I highlight and still have it pass a horizontal line test? Could I highlight this much? No, it doesn't pass the horizontal line test. That passes the horizontal line test. Could I highlight more and still pass the horizontal line test? Yes. Could I highlight up to here and then stop right at the vertex? So if I stopped right at the vertex and I just had half of the parabola, can you see that half of a parabola would pass the vertical line test? So if I do the first way here, which is our yellow part, how did I restrict the domain? Well, I looked at my vertex, and my vertex on my graph is 1, 3. So if I just looked at the yellow part, I'm just looking at the values where x is less than 1. And if x is less than 1, that's just the yellow part of my graph, and it would pass the vertical line test. We're going to look at finding the equation of the inverse for this half. Now, finding the equation of the inverse is where you switch the x and the y. So if I did that, I would get x equals bracket y minus 1 squared plus 3. And if I solved for y, first I'll get the squared by itself by subtracting 3 on both sides. Square root both sides. Don't forget the plus or minus. And add 1 to both sides. And I'll just write it like this. This gives us two possibilities. It gives us one possibility where it's positive and one possibility where it's negative. So now we have to figure out, when we did the yellow part of our graph, when we did that half, will that be the positive half or the negative half? So let's look. Well, what's going to happen to the point 1, 3? It's going to go to the point 3, 1. Take another point on the yellow part. Can you see that you have the point 0, 4 on that yellow section? Where is that point going to go? 4, 0. If we drew this as our starting point, which part of our graph do we have? Is it the square root that's positive or the square root with a negative out in front? It's the square root with a negative out in front because you would need a reflection over the x-axis for it to be down below like that. So our first way to restrict the domain would be to take our vertex and do everything to the left of it, because that yellow part passes the horizontal line test. And then when we draw the inverse of just the yellow part, it passes the vertical line test. So I'm just going to highlight this line with a little bit of bright yellow so we remember that that one went with the yellow highlighted part. And now if we take a different highlighter and highlight the other section, and that'll be our second way to restrict the domain. Now what do we have to say about our x values? Now we're looking at our x values where x is bigger than 1. If we restrict it when x is bigger than 1, what's our equation going to be? Well, now if I took this point here, which is on our original graph 2, 4, we would have 4, 2. And I'm just going to draw this part in green to say that that is connected to the green part. And so our equation of that one is the positive square root that we found. So again, we've used our graph. Only by color coding can we show what we're talking about. Because if you would draw this, or you'd have to label it in such a way so that you can make sure that you're connecting your green highlighted part of our graph with the green equation. And we have the yellow part of our original graph connected to the yellow/blue graph. That was our inverse. So sometimes we need to restrict the domain of our original one so that our inverse is a function. Okay, questions for this one, and we are going to take some time to work on all of these, are 10 and 12.